This is for Chapter 3.3 written textbook homework. Here are the two problems assigned for 3.3. It was problem 6 and problem number 9. The first problem has to do with calculating mean and standard deviation again, but this time the data is what we call grouped. So you can see it's already been organized for us, and so we call that grouped or binned data, as we discussed. This is grouped, or, that's an or. We say binned. They can put in trash bins or in containers. So they're in the containers from 0 to 999, 1,000 to 1,999. So the weight is actually the weight of a baby, the birth of a baby, how many grams, and then the number of babies born between those weights. And because we don't have the exact values, we cannot calculate the mean and standard deviation in the previous way. So that's an important acknowledgement. I can't just add up all of them and divide. We have to use a different technique, and it's a really complicated technique. The formula is here, so it's a long time to, the mean is not that bad, but the standard deviation by hand is not good. So what we do is we're going to use Statcrunch to do this calculations for grouped or bin data. The key is that you get this data in correctly. Again, this is the work by hand, which then could potentially lead to some rounding errors, but this is the work done by hand. And so for Statcrunch, what happens is in Statcrunch is you end up getting in the data. So here's the grouped data already. And then what we do is summary statistics like we've done before. And then this time you go to grouped or bin data. And then the bins are in the weights. And then number of babies is here. And so what you're looking for is, we just want standard deviation and mean. And so let me get that, there we go, and compute that. And then you got your answers there. That would be your standard deviation mean, and that would be your answer for number 6. You'll see we're off a little bit, but again, it's because the computer is doing the exact calculations. Draw a frequency histogram of the data to verify the distribution is bell-shaped. So again, we take this data here and then we graph it here. You see you have this nice kind of bell-shaped. Most of babies born are between 3,000 and 4,000 grams. So you would have a distribution looking like that. Make sure what we're looking at here also is and again, because the graph is symmetric or bell-shaped or normally distributed, we can then apply the empirical rule 68%, the 95, 60, 68, 95, 99% rule. And so according to the empirical rule, 68% of the babies will be between what weights? And so what you can see is, again, remember 68% of all values fall within one standard deviation of the mean. And so again, using the values from the book, this is what you would get. If you use the values from Statcrunch, you would get slightly, which I guess I already eliminated, you get slightly different values, but your answer should be within very close to these answers here. And that's for number 6. Number 9, it's a simple formula, and really for this, these are weighted averages. And don't get that confused with the weights of a baby, but weighted averages are like your GPA, and that's kind of really, I just kind of focus on something beneficial for you to be able to calculate a college GPA because it's weighted based on the number of units a class is. So an A in a 5-unit class is different than an A in a 2-unit class or a 3-unit class. There's different weights, and so again, it's the weight times, so the weight times the value you get. So B is a 3, and A is a 4, and so forth. And so for this one here, you would just plug it in, and you get 3.27. Can't use Statcrunch on this one. You got to do this one by hand or calculator. And then again, remember this means that's the sigma notation. Just add them all up and then divide. That's it.